It's Thomas LETAN from TEZOS. Warm welcome to Thomas. Please join me on the stage. Here is your pointer. And the stage is yours. Warm applause, please. Thomas.
Good morning. Okay, so does it work or not? Nope. Okay. Okay, it works. It works too well. Not. Okay. Okay. Sorry about that. So, good morning. My name is Thomas LETAN, and I'm working at a company called Nomadic Labs, and we're working on the TEZOS blockchain. So, out of curiosity, and I don't see you very well, but out of curiosity, who knows TEZOS here already? And so, I hope you will be excited to know that this year TEZOS is becoming EVM compatible. And today I will use this opportunity, and thank you for inviting us to discuss here, to explain a bit how we are doing that. So let's first discuss about TEZOS itself. I won't spend too much time talking about the details, but the key idea that you might need to know to understand the rest of the talk. The first one being that since from day one, we had an on-chain governance system that we used to propose to the community new upgrades for the TEZOS blockchain. And it's important to understand that it's fully permissionless and fully open, so anybody can propose new upgrades, and it actually happened. I think now it happens quite every time that other people from the ecosystem is proposing new upgrades. And we had something like 14. If I remember correctly, we had 14 upgrades on TEZOS mainnet since the beginning. And this on-chain governance, it really helps us moving forward over the year, so over the 5 previous years. And in particular, for instance, we've been able to hot-swap the consensus algorithm to go to a deterministic, fully deterministic finality algorithm that is called Tenderbake. We have also been able to rewrite completely our smart contract virtual machine. So TEZOS has its own smart contract language, which is called Michelson. So it's not EVM, not Solidity. And more recently, we've been able to bring on mainnet, we've been able to bring optimistic rollups as a first-class citizen, like a first-class citizen optimistic rollup platform on TEZOS mainnet. And we are very excited about this smart rollups, as they are called, because we think that they are a game changer for TEZOS. They allow, for instance, horizontal scaling. It was probably one of the main initial motivation to get optimistic rollup on TEZOS, was to prepare for the future to be able to scale horizontally. And we've been able to demonstrate on open testnet 1 million TPS demo with using 1,000 rollups, which is not a small feat as far as we are concerned. But apart from that, apart from the horizontal scaling, what is very interesting for us and for the ecosystem is the new possibilities and the new use cases that smart rollups opens. And I will have the opportunity to discuss more in detail why. But in particular, we will use this avenue of new layer 2s on TEZOS to bring EVM compatibility on TEZOS, which was something that I've been asked for a long time, and that we are happy to be able to pursue with this layer 2 solution. So out of curiosity, to which extent are you all familiar with optimistic rollups? Okay, so a bit of context, basically. So you have various opportunity to scale horizontally and with layer 2s. Optimistic rollup in particular consists in a particular trade-off where you bring new computational power to your ecosystem, to your layer 1, but you do that with a bit of a trade-off where you ask for infrastructure cost instead. So basically, the main idea is that compared to smart contracts, where you execute your decentralized application on the layer 1 itself, on the main network, by all validators. The optimistic rollups allows to move this computation off chain. And so this is why you need some infrastructure in addition to what the layer 1 provide. But when you do that, you get a lot more computational power, and you in the case of the smart rollups that we are proposing on mainnet since March, you are in control of what is happening on the smart rollups. And so smart rollups are really a new way for Tezos to write decentralized application, and it's a way that is a lot flexible to a large extent. So it's not the first time that we are presenting smart rollups, and we have a few properties that we like to put forward when we do that. The first one that set us apart in the realm of optimistic rollup for now is the fact that they are fully permissionless as far as the layer 1 is concerned. So anybody can create smart rollups, anybody can track existing track, and by track I mean computing the state of existing smart rollups, and more specifically anybody can defend the state of the smart rollups. And in particular it means that for interactive fraud proof, they are also permissionless, and if you have an interest in seeing a particular layer 2 optimistic rollup that is living on Tezos be protected because you have asset on it or something like that, you can start your own node and potentially defend it against attackers. The second thing that we like to put forward is that they are enshrined, and by enshrined what we mean is that they have been implemented as first-class citizens of the Tezos protocol, instead of implementing on top of the Tezos protocol as smart contracts. And this gives us a lot of flexibility to, in particular, think very deeply about the interoperability of the smart rollups on the one hand and the existing components, and by that I mostly mean the smart contracts of Tezos. It's also a good opportunity for us to improve a lot, or at least to care a lot about the optimization of the implementation of these smart rollups, and typically to reduce the cost related to the layer 1. And I think like Tezos smart rollups are very, very cheap to operate thanks to that. In particular, in terms of storage cost and things like that, we've been able to have some optimizations that reduce the cost dramatically. And finally, and this is a bit the dual of the first property, they are fully programmable. And what I mean by that is that when you create a smart rollup on Tezos, you provide a WebAssembly program. And this WebAssembly program is the thing that will decide the semantics of the operation and the transactions that are happening on the layer 2. And because you are the one that is creating the smart rollups, you choose this program, and you have a lot of freedom and flexibility about what you want your smart rollup to be. So it can be a very specific thing curated to your chain, to your needs, sorry, and so you will build something like an app chain, or it can be something that is very generalized, like a generalized layer 2, like for instance, Arbitrum can be for the Ethereum ecosystem, and yeah, these use cases can be addressed by the smart rollups. So we are very excited about this solution. The nice thing about the smart rollup being enshrined is that the rest of the ecosystem of Tezos has to care about them, and they have to support them. And this is actually pretty nice. So for instance, every time you create a smart rollup, you get for free, to say, a page on, for instance, TZKT, which is a popular indexer on the Tezos ecosystem, that will give you ideas about who is publishing states, or what kind of smart contract are interacting with your smart rollup. In addition, you can visualize the fraud proof. So we are calling them refutation game. If you happen to try to read the documentation that we have published, don't be surprised. We are talking about refutation game, and you can see the list of games that have happened for a given smart rollup. So hopefully the list will be empty. Here it's on a test net, so we've actually used this opportunity to test the fraud proof. And so it was not on purpose, but one thing that I like about the screenshot is that it shows how permissionless they are and how decentralized the games are. In particular, you see that you have two players, but it's actually a third player that is concluding the game. It's a particular edge case where the players stop to play, and a way to unlock the rollup to some extent. And it shows that what we try to do is, if the identity of the person that is injecting the operation is not relevant, then we don't care about it. And we try to leave as many doors open so that as many interested parties, I would say, are interacting with the rollups. So I won't spend too much time explaining technical details, but very quickly, if you're a developer, a DApp developer, and you want to use smart rollups to implement your application, what does it look like? So the key idea is that you have your WASM program, which is run in your layer 2. And this smart rollup program, this WASM WebAssembly program, will have first to fetch data, right, at least from the layer 1. And this is done through what we call the shared inbox. And the shared inbox is really the components that receive all the transactions that go through the layer 1. So one way to inject operation to your smart rollup is to post an operation, a dedicated L1 operation that is transmitted automatically to the layer 2. But if we stop there, then the story becomes a bit strange, because I said a bit before that we've been able to demonstrate 1 million transactions per second on Open Testnet, and 1 million transactions per second is a lot of transactions, and most likely they come with the signatures, or at least in our demos it's the case. We have 1 signature per transaction, and so it takes a lot of space. So how do you deal with that? Well, you deal with that with what we call the reveal channel. And without entering too much into the detail, because if I remember correctly, this is the subject of the next slide, but the reveal channel is a way to import data of arbitrary size inside the rollup. And by doing that, what you get is a way to import megabytes, if you want, of data in your rollup, without having to pay for megabytes of block space in the layer 1, which is both neat and actually needed if you want to scale for use cases like retail or logistic, where you can have a lot of operation, like a huge volume of transactions that will happen from time to time. Then you are able to fetch data inside your rollup. You have something called the durable storage that can be used to retain data. So it's really the storage of your smart contract, but in a way where you don't have to pay for storage, because you have everything that is getting care of off-chain, and so you don't have a way to pay for storage that is used on the validator's nodes, for instance. So basically, the durable storage don't have particular limits in terms of the volume of data that you can store. It has limits about how you store them, but these are technical details related to the refutation game. And as I will have the opportunity to discuss, we try to hide these technical quirks with an upper level of software components. And finally, you have interoperability with the layer 1, not only by sending data, but by sending back data to the layer 1. And by data, I mean really L1 transaction. So you have a way for your smart contract to interact with, for your smart rollup, sorry, to interact with the smart contract. And it does that by sending a message to its outbox. So optimistic rollup brings a bit of friction here, and maybe a bit is an understatement, but you have friction with sending back data to the layer 2, at least in the native way, but it's possible. And so after enough time left for the nodes that are computing your rollup state to verify that this state is correct, you can actually realize this layer 2 to layer 1 operation. And another thing that is important to understand is that every time a Tezos block is created, then you get execution time on your layer 2. You don't have to pay for a layer 1 gas because you are not executing by the layer 1, and you get that for free. And so you can have a lot of freedom again, and a lot of versatility on how you deal with this execution time. And one thing, for instance, is that you can decide to send your data by large chunk and spend several Tezos blocks to compute them. And this is also another way to reduce the operational cost with respect to the layer 1 by batching your data effectively. So the reveal channel, one thing that is important to understand is that it doesn't have to be, but it can be a compromise on decentralization, because because the question of data availability become more concrete. for you. So if you send your operation to the layer 1, then the layer 1 is the data availability solution that you use. Your data are inside the L1 blocks, and so you don't have to ask yourself how the other users that want to compute the state of your rollup will fetch this data. The layer 1 will fetch them. If you are starting to using the reveal channel, where data are not strictly coming from the layer 1, but from the outside world, then the question of whether or not you will give this data to your user, to the other parties that want to compute, the third parties that want to compute your rollup, becomes more present. So what we try to do, I think it's not a bad thing, in the sense that not all smart rollups need the same level of decentralization. But what we try to do as a Tezos core developers is always to find a way to make you enjoy the most level of decentralization that we can. And in particular, so we've built something that we call the DAC, Data Availability Committees, which is a tool suite, that you can use already, and will act as a third-party provider of data availability, where you would have committee members signing data that you want to inject on your smart rollup, and the semantics of that signature would be that they agree to keep the data available for anyone asking for a certain given amount of time. But again, here we are basically relying on a multisig and the trust that the member of this multisig will do as they say, which is always great enough for a lot of use cases. But if you want more, we are actually building something that we call the data availability layer, which is basically a huge DAC where the member of your DAC are the validators of the Tezos layer 1. And so again, you would have this data availability enforced or at least ensured by the validator of the layer 1, the same way as the validators of the layer 1 are already ensuring the availability of the L1 history. So if you, behind this QR code, if you're interested, you will find various blog posts explaining both solutions, their respective timeline, and what you can do with them already. And this is only the beginning of the journey. We had a very developer-centric point of view here, and I'm sorry if it was too technical, but once you have your WASM program, once you have the semantics of your DApp, basically, that is expected to run on a smart rollup, you still need to care about how it will be executed, because, as I suggested, before, with a smart contract, it's done by the layer 1 itself, it's done by the validators of the layer 1, and with a smart rollup, it's no longer the case. So you have to answer yourself, you have to answer the question of who and how will your smart rollup will be executed. To do that, so the first thing is that we give you the tool to build it. In particular, we have invested a bit of time and effort in providing a high-level type-safe framework for the app builder in the Rust language. So the Rust is not something that we force on you. If you don't want to use this SDK, you can. But we think that it has a nice property when you try to build something that potentially will handle a lot of data and a lot of money, and you don't want this money to be lost because of bugs. And Rust has a nice property in terms of development that allow to eliminate a large class of usual bugs. We provide also tools to test, inspect, benchmark your smart rollups, which is something that you will definitely want to do. And more importantly, maybe we are providing a general, we call it the rollup node, a general purpose node that will work with your WASM program without having to be modified. So it's really on-the-shelf solutions that you can already use, and that will make it possible to actually compute the state of your rollup, to define the state on the layer 1, etc. And of course, we have I don't know if it's that obvious, we have a track record in providing new features to Tezos. We like to think of Tezos as the blockchain designed to evolve, and we have the same kind of ambition for the layer 2 solutions that we are building. And in particular, it means that the smart rollups as they are now won't be the smart rollup of 2 or 3 or even 3 years in the future, or even a few months in the future. Actually, we already had the opportunity to improve them with the upgrades, the Tezos upgrades that came after the one from March. So in March with Mumbai, we delivered the smart rollups to the Tezos mainnet, and with Nairobi that came, I think, 3 months later, we actually brought new features to smart rollups. Okay, so coming back to the EVM compatibility. So Tezos, as I said, has its own smart contract language that we think has very good properties, actually, in terms of building smart contracts. That being said, we have had partners that were interested in EVM compatibility for Tezos, and it makes sense in the sense that they potentially had already an existing Solidity code base, and they wanted to deploy on Tezos, but they couldn't for free, so to speak, in terms of time of development. So EVM compatibility was something that was requested a lot of time, and we didn't want to add it directly to the layer 1 because it was not the correct layer for us. But with the layer 2 and the freedoms that they brought, it became suddenly a lot more easy for us to actually bring EVM compatibility to the Tezos ecosystem. And this is what we are doing. And when we started, we've quickly discovered actually that an EVM compatible rollup doesn't mean much, or it means too much actually, in the sense that you have a lot of questions that you need to ask yourself before even starting to build your own solution. And you have a lot of cursors to point in various directions depending on your needs. So for instance, do you need low latency in your decentralized application? Most of people do, not all. And low latency using a sequencer bring a lot of challenges in terms of decentralization, because most of the time what they are relying on in particular are centralized sequencer. Another thing is that do you need these arbitrary size blocks or data to inject in your rollup or not? Because those bring other challenges that you need to address if you do. Maybe a bit more surprising, but do you need to pay for gas? In the sense that if you are just interested in a place to deploy your contract, and your decentralized application does not have to interact with the rest of the world, for instance, then maybe you can just have an app chain where you close the doors, but basically people can still look at what is happening, but not inject new smart contracts. And so maybe you don't have to pay for the gas at all. So this is, at the end of the day, what you have to do is ask yourself this bunch of questions and draw this kind of skill maps where you choose on different cursor where you want to be, and what are the compromises and what are the things that you are willing to do. And it's a bit too soon for Tezos to answer this question for the rest of the ecosystem. So what we are trying to do and what we are building is a layered answer, where first we are trying to keep the WASM program of our EVM rollup as customizable as possible, in the sense that it should be easy, and it is easy, to take the code that we are writing, to tweak the various parameters that I've talked about, and to get your own EVM rollup up and running on Tezos network. That being said, we don't want to stop there, and we are actually in the process of building one instance in particular, an instance where we will put the cursor of decentralization and reducing cost as high as possible, the cursor, not the cost. And so this is our community EVM rollup, and it's a community in the sense that we want it to be a common good for the Tezos ecosystem, a place where you can deploy your Solidity application and enjoy the interaction with the rest of the Tezos ecosystem. And again, if the choices that we are making for the community rollup does not address your particular use cases and your requirements, then you can take the template and redeploy it as expected. So basically, the way we are addressing that is by organizing the code in a way where we deal with block proposal and then validating the block, because these two phases are each one has their specific answer to answer, question to answer. And we also have to care with the rest of the ecosystem, like with the compatibility with the existing Ethereum ecosystem. It would be a shame to start being EVM compatible and not working with all the amazing tools that have been built by the Ethereum ecosystem. And to do that, it's actually a bit of more work for us, in the sense that we don't speak the same language or the same APIs as the rest of as the Ethereum ecosystem. So we are actually building a node that is able to talk, or at least to propose the Ethereum JSON RPC API. And this node is already compatible with a bunch of tools. So for instance, you can already use MetaMask with it. It's already compatible with BlockScout, the indexer, and it's already compatible, or at least partially compatible. I think there are some challenging remaining, but with Remix, the IDE, online IDEs that you can use to test and deploy your smart contracts. And maybe it's compatible with your decentralized application, but maybe it's not the case. So we already have actually a public instance on a testnet that is running the EVM rollup. And you can find some details on following this QR code. And so if you have some time to spare or some interest in coming to the TEZOS ecosystem, I really encourage you to have a look at this blog post and to come to our Slack and ask any question, or report your problem and your successes. It will be very welcome. That being said, we are becoming EVM compatible with this community rollup that will be called Etherlink. And if you are interested in that, please feel free to go to etherlink.com and register to the mailing list that we have. Globally, we have a lot of ambition for this project. Okay, and to conclude this talk, I don't know if I'm running late or not, but just in case. What's coming next for TEZOS? It's far from being over for us in terms of the optimistic rollups and what we want to build with them. The smart rollup as they are now, they are already ready for your industrial use cases, but this doesn't mean that we cannot improve them. And we will do so, in particular by exploring vertical scaling inside the rollup. So I mentioned very briefly at the beginning of the presentation that we are already able to do 1 million transactions per second on testnet using 1,000 rollups. And 1 million transactions, it has a nice rank to it, right? But what we want to do now is try to reduce that, but not with 1,000 rollups, but just with one. And so you would get the vertical scaling of being able to get your own computation time on TEZOS almost for free, or at least with very small layer one cost. And what we want to do is to allow you to scale vertically, which means, for instance, buying a more powerful machine to handle more data if you so desire. Also, we want to build a universal computing platform. And this is maybe coming back to the fact that for a long time, TEZOS has its own smart contract language with a lot of good properties, but with, I would say, some friction for the app developer. And we have a story about bringing EVM compatibility, but we also have a story of other languages that have good properties that are not available on our network. And we want to build a platform where you could implement your smart contract in the language that you chose, and to deal with that for you, to deal with the interoperability with the rest of with the other runtime and the other languages, and so be very welcoming in terms of adoption from this perspective. And so this will be something that we are starting to work on today, and we hope we will accelerate on this subject in the course of the next year. But of course, this year is more about EVM compatibility, at least for the layer 2 part. And again, so it is coming on TEZOS mainnet this year with Etherlink, and potentially other and as many EVM rollup as the ecosystem needs to have. And if you have a Solidity decentralized application that you would like to test on a new fun environment with a bit of bleeding edge and fun quirks, for now, don't hesitate to reach out to us so that we can see that happening. We already have some partners that have had some success deploying, for instance, NFT platforms and things like that. Thank you. And yeah.
Thank you, Thomas. So, as a corporate baker, I can only support TEZOS. Thank you very much. Yeah, perfect.